So in this lesson, let's learn about Gauss elimination. So Gauss elimination, it's a systematic way to solve linear system of equations. And by now we also know that an augmented matrix, so an augmented matrix also represents a linear system completely. So we can perform Gauss elimination on the augmented matrix. So in this lesson, I'll be performing Gaussian elimination on the linear system of equations, and to show the one-to-one correspondence with the augmented matrix, I'll also write the augmented matrix side by side with the linear system of equations, and I'll perform the Gaussian elimination on the augmented matrix as well. So all right, so let me take an example here to illustrate these concepts. So let's say we have the following linear system of equations. So let's say we have x1 minus x2 plus x3 is equal to 0, and let's say we have minus x1 plus x2 minus x3 is equal to 0, and let's say we have got 10x2 plus 25 x3 is equal to 90, and let's say we have 20x1 plus 10x2 is equal to 80. And now I will perform a series of elementary row operations on this linear system. And we also know that performing elementary row operations on a linear system does not change the solution. All right. So let me also write down the corresponding augmented matrix here. So this will be 1 minus 1 1 0 and minus 1 1 minus 1 0 and 0 10 25 90 and 20 10 0 and 80. All right. Please also note that I have refrained from putting a bar here just after the coefficient matrix. In some of the textbooks, they insist on putting a bar to differentiate between the augmented matrix, the coefficient matrix and the constant terms. You can even skip that. It's really not required here. I'm not going to be putting any more bars in the augmented matrix. All right, so the first step, or let me call it like this. So the first step, step 1. So step 1 is to call the first equation the pivot equation. So we will call the first equation, this guy here, the pivot equation. All right. And we will call the first unknown, that is x1 in this case, in the pivot equation, the pivot. So let me circle this. So this guy will be called the pivot. Okay. And now we will use the pivot equation, or this equation here, this guy, we will use pivot equation to eliminate or get rid of x1, which is the pivot, in all the other equations. Okay. So let's see, x1 appears in equation 2 and in equation 4. So we are going to be using pivot equation to get rid of the pivot, that is x1, in all the other equation except the pivot equation. And the way we are going to do this is via elementary row operations that we studied in the last chapter. So what we can really do is that we can add equation 2, we can replace equation 2 with the sum of equation 1, 1 and 2 to get rid of x1. And for the fourth equation, what we can do is that we can subtract 20 times the pivot equation. Okay. from the fourth equation. So we can actually multiply the pivot equation 20 times and subtract it from the fourth equation. So this will give me a new linear system with the same solution indeed, right? So this will give me a new linear system. It will be x1 minus x2 plus x3 is equal to 0. And here if you actually add equation 1 and equation 2, you will get 0, because x1 minus x1, and then you have x2 minus x2 plus x2 and x3 minus x3. So this takes the form of 0 is equal to 0. Interesting. And the third equation of course did not have any x1 term, so we can write it as it is. 10x2 plus 25x3 is equal to 90. And for the fourth equation, what we did was we multiplied pivot equation with 20 and subtracted it from the fourth equation. So we will indeed get rid of the x1 term, and the resulting equation here will be 30x2 minus 20x3. And is equal to 80. All right, and the corresponding augmented matrix will be 1 minus 1 1 0 0 0 0 0. Okay, and 0 10 25 90 and 0 30 minus 20 and 80. Okay, so this was step 1. So just to recap again, in step 1 we chose the first equation as the pivot equation and the first unknown in the pivot equation as the pivot, and this was x1. And then we used the pivot equation, that is the first equation, to get rid of the pivot, that is x1 here, right, in all the other equations except the pivot equation. And the way to get rid or eliminate x1 in all the other equation, we were able to do so by using elementary row operations. All right, so after step 1, this is what we get, and this linear system of course will have the same solution as the original system of equation. Okay, now step 2. Okay, so in step 2, the first equation which just served as the pivot equation, now it will remain untouched. We will not touch it again. But what we want to do now is we want to take the second equation now as the new pivot equation. Now unfortunately the second equation contains no unknowns, right, because it's 0 equal to 0. So what we need to do is that we will change the order of equations and the corresponding rows of the augmented matrix to get a new non-zero pivot. So we put the second equation, that is 0 is equal to 0, in the end. So we will put it in the end here, and we will move the third and the fourth equation one place up. So we will move the third equation here and the fourth equation here. And likewise we will do the same operations for the augmented matrix. Okay, so if you do that, let's see what's going to happen. You will get a new linear system which will be x1 minus x2 plus x3 is equal to 0, and 10x2 plus 25x3 is equal to 90, and 30x2 minus 20x3 is equal to 80, and 0 is equal to 0. All right, and let me write down the corresponding augmented matrix too. So it will be 1 minus 1 1 0, and it will be 0 10, 25, 90, and 0, 30, minus 20, 80, and then all zeros. Okay, so till now with me, right? Now once we have this, the second equation serves as the pivot equation, and the first unknown in the second equation now, which is x2. Okay, so x2 serves as the pivot. All right, and we will use x2, and so what we need to do is to eliminate x2 from all the other equations now, all the equations lower here. Remember, we will not touch the original pivot equation, the first pivot equation. We are done with this guy. Okay, so what we want to do is that we want to actually eliminate x2 in all the other equations of this linear system. And the way to do that would be, again, we will be using elementary row operations. To eliminate x2, we need to subtract 3 times. So you multiply 3 times and subtract this pivot equation from the third equation. Okay, and so the result will be, you leave the first equation unchanged, so this will remain x1 minus x2 plus x3 is equal to 0, and the second equation, of course, this guy also remains unchanged. So 10x2 plus 25x3 is equal to 0. I'm sorry, this will be 90. It's easy to lose track of numbers when you're doing this, and this will become minus 95x3 is equal to minus 190, and the fourth equation is 0 is equal to 0, and the corresponding augmented matrix will be 1 minus 1 1 0, and it will be 0 10 25 90, and 0 0 minus 95 minus 190, and 0 0 0 0. All right, so now once we have this, we can actually work backwards now. So now we have this equation, right? So we can work out what x3 is. So from 95 x3 is equal to minus 190, we can work out that x3 is equal to 2. Now let's go to the second equation. So we know that 10x2 plus 25x3 is equal to 90, and this implies that x2 is equal to 1 by 10 times 90 minus 25 x3, and you can work it out. I think it will be 4. Okay, and now you move to the first equation, and you know that x1 minus x2 plus x3 is equal to 0, implies that x1 is equal to x2 minus x3, and this will be 2. Okay, so this is the solution to our problem: x1 equal to 2, x2 equal to 4, and x3 equal to 2. So this is the solution to our problem, to this original linear system. Now this linear system is overdetermined, so let me write it down. This linear system is overdetermined, and what it really means is that it has more equations than unknowns. So the number of equations is more than unknowns here, right? Because the number of equations we had are 4, right? We have got 4 equations here, and the number of unknowns are just 3, x1, x2, and x3. So such a system is known as overdetermined. There is something also known as a determined system, determined linear system. So let me write it down. Determined linear system. So if the number of equations is equal to the number of unknowns, such a linear system will be known as determined. And there is something called an undetermined system too. Undetermined. And in this case, the number of equations is less than the number of unknowns. Let me write it like this: number of unknowns. So the number of equations is less than the number of unknowns. And I'll show it to you, and probably, maybe you can actually get it yourself right now, that an undetermined system will always have solution. So this guy will always have solutions. Always have solutions. Whereas in the other two cases, the solution may or may not exist. May or may not exist.